Hi there, GoodGolf here with a new video. As part of the series on how to create a survival game, this episode covers custom A-star pathfinding. How we give NPCs and monsters the ability to navigate across our procedurally generated streaming terrain. I missed this as a topic in our to-do list from the first episode, and we definitely need this in a survival game. The code will be available as a GitHub repo so you can play around with it. Okay, let's start with the basics. Why build a custom pathfinding solution when Unity already has NavMesh? The answer is our terrain. NavMesh needs to be baked against a static geometry, but our world is procedurally generated at runtime and streams in and out as the player moves. There is no static geometry to bake against. We need a pathfinding graph that builds itself on the fly, updates when a new terrain chunk is loaded, and stays fast enough that enemies can navigate without causing frame drops. So instead of NavMesh, I built a custom A-star system. Here is what it includes in this first version. A grid-based pathfinding graph that maps directly into the streaming terrain. Burst-compiled jobs for rebuilding the graph when new chunks load. A double buffered NativeArray design so rebuilds never stall a running path search. An async physics obstacle overlay pass that spreads its work across frames. A static obstacle cache so physics checks are skipped for geometry that hasn't changed. Configurable graph resolution, defaulting to one node every 2 meters for performance. A pathfinding agent component with move to, patrol, line of sight, and leader-follower flocking. You may remember from the first episode in this series that I mentioned I would use available solutions when possible. If you have seen earlier videos in the channel, you may know that I'm a big fan of the A-star pathfinding project by Aaron Grenberg. I could have picked that as a solution here. However, this early in the series I wanted to be able to still share the full demo project, and that would be a no-go. If you want to go full featured on pathfinding, I strongly suggest checking his solution instead of building your own. The pathfinding graph is a flat integer grid in the XZ plane. Each cell covers a configurable number of world meters. We default to half a node per meter, meaning one node every 2 meters. The y-coordinate is not a navigation dimension, it's data stored per node sampled from the terrain height map. Each node stores 4 things: the terrain height at that position, the approximated surface normal, a walkability flag, and its own flat index into the array. Keeping this as a blittable struct means that it can live inside a native array and can be written by burst jobs with little overhead only. The key design principle here is the double buffer. The graph owns 2 persistent native arrays of the same size, buffer A and buffer B. Buffer A is the live buffer that path searches read from. Buffer B is the staging buffer that burst rebuild jobs write into. When a rebuild completes and no searches are currently in flight, the 2 buffer references swap instantly. Agents keep navigating on clean data the entire time. The terrain graph integration component sits on the same game object as the terrain streaming controller. It listens for the on-chunk load complete event and only registers a chunk once its height map has been fully written by the terrain generator. This is a crucial timing detail. Registering a chunk too early means reading blank zeroed height map data and every node ends up as unwalkable. Once enough chunks are registered, it calls build or resize graph. This sizes the graph to cover the unload radius around a player in world space, converts those world bounds to node grid units using nodes per meter, and allocates the 2 native arrays. The graph is sized generously upfront, so it rarely needs to grow during normal play. When only a small area of terrain changes, say an explosion or a player digging, we use a partial rebuild. A copy buffer job first blitzes the live buffer into staging so untouched nodes survive. Then a partial graph rebuild job overrides only the nodes within the dirty region. After the burst job finishes, we need a second pass to mark nodes blocked by physics colliders, rocks, buildings, walls the player has constructed. The physics API cannot be called from a burst job, so this needs to run in the main thread. To avoid a stall, the overlay pass is spread across frames. We'll cover this in the next video. The pathfinding component handles 4 behavior modes: move to a target, patrol a list of waypoints, approach or flee from the player using line-of-sight raycasting, and follow a designated leader with a flock offset. Terrain height snapping uses a downward raycast from above the agent each frame. If the raycast misses, which can happen near chunk boundaries or if the terrain layer is not in the mask, it falls back to sampling the pathfinding graph's stored world Y value for that position. This keeps the agent grounded using the exact same high data that was used to build the path. This is a short introduction to the code, which can get you started exploring how it all works. I uploaded a package for Unity 6, which you can use to test the current version. Note that I included a quick and dirty character controller, since I cannot include the easy character movement controller in a package uploaded to GitHub. If you want, you can find it in the asset store and patch it in easily. Okay, that's it for this work in progress video. Next up is integrating pathfinding with the build system, so newly placed constructions update the graph in real time. And after that, adding fishnet networking support. If you liked the video, then please give it a thumbs up and I will be back in the next episode.